Get me more pieces of chalk. No, human, pass this way. The rest, stay where you are. Don't encroach. Human, I'm going to stop any movements now. So, good morning, ladies and gentlemen. How are we? Human, go out. Are you a physicist? You see, it is the teacher who is supposed to come last in class. But human, look here. Eh? Take it easy. It is something common in Kampala there. So where did we stop? Pass this way. Human, block that path there. Block it with your desk. So we had gone up to as far as the factors that affect the heat cap. I mean the capacitance of a capacitor, right? Meaning we are supposed to go to relative permittivity, right? So write a subheading: relative permittivity stroke dielectric constant. Had we looked at that? You know, you are two classes that I meet, so I must have taught it the other side. Relative permittivity stroke dielectric constant. Relative Wajamin, what's the matter? At this level, we should not be having wrangles this kind. At this level, we should be busy, academic minded. So what do you guys know by relative? I think I've talked about it, or we talked about it the other time when we are looking at Coulomb's law, isn't it? Looking at the force that affects charges, or the force between two charges being proportional to the product of the magnitude of the charge, but inversely proportional to the separation between them. And now that constant K, which was equivalent to 1 out of 4 pi epsilon, that epsilon was defined as what? As permittivity. So that permittivity, it depends on if the charges are in free space. The permittivity is simply the permittivity of free space. But if the charges are placed in a medium, then the permittivity of that medium is considered, of which we can compare it with the permittivity of free space. And the comparison of the two permittivities is what we called the relative permittivity. So basing on those facts, how can you now define relative permittivity? Any volunteer? Yes, man. The ratio of the permittivity of a material to the permittivity of free space. Now, it is actually the same thing here that we are going to put in place. Though, under capacitance, we are going to look at it as now the capacitance is, because you remember we said that factors that affect the capacitance of a material, one is the cross-section area or the area of overlap of the plates, right? And this one varies or it affects in a direct proportionality. That when you increase the area of overlap, you will have increased the capacitance of the capacitor, right? Two is the separation between the plates. Once you increase the separation between the plates, you will, in other words, be reducing the capacitance of the plates. I think that's what we say. Then the third factor is the permittivity of the medium or the presence of an insulator between the plates. And in this case, we say that the more you bring an insulator between the plates, you will be building the capacitance of the capacitor. So in this case, the relative permittivity or the dielectric constant of a capacitor is now going to be the ratio of the capacitances that when you have one capacitor whose space between the plates is filled with an insulator, get the capacitance. Then compare it with the one whose the space between the plates has no insulator. The ratio of the two in this case is the relative permittivity or the dielectric constant. You can take note. It is defined as the ratio. It is defined as the ratio relative permittivity or dielectric constant is defined as the ratio of capacitance of a capacitor, the ratio of capacitance of a capacitor, the ratio of capacitance of a capacitor when the insulating material in brackets dielectric, when the insulating material in brackets dielectric is between its plates. When a dielectric material, when an insulating material stroke dielectric is placed between its plates to the capacitance of the same capacitor, to the capacitance of the same capacitor, to the capacitance of the same capacitor when a vacuum actually don't say when, with a vacuum between its plates, with a vacuum between its plates, with a vacuum between its plates. So get a capacitor, find its capacitance when it has nothing between the plates, record it. Get the same capacitor if it was parallel plate, the same area of overlap, the same separation between the plates. Now this one, fill it with a dielectric, then record it, the capacitance. Now you divide the two and get what we are defining as the dielectric constant. This is what we mean. Dielectric constant or relative permittivity equals capacitance C of a capacitor with a dielectric between the plates divided by the capacitance of the same capacitor with the same features, apart from the fact that for this, the gap between the plates must be filled with vacuum. Now the remaining work is algebraic gymnastics. So we can have now the capacitance of that capacitor is going to be ER C naught. But capacitance of a capacitor without or with an insulator between the plates is equivalent to quoting the factors that affect the capacitance of a capacitor. So C, which is not C naught, equals epsilon. Now this is the permittivity of that insulator in between the plates, times the area of the overlap divided by the separation. This is the capacitance of the capacitor whose space between the plates is filled with a dielectric. Now, epsilon here is the permittivity of that what? Dielectric. Now, we also have C naught, which is now epsilon naught, because now this is the capacitance of a capacitor whose space between the plates is filled with vacuum. So times A, because we said these ones are supposed to be the same, divide by the separation D. So if we substitute these two here, we shall have epsilon R being epsilon A over D divided by epsilon naught A over D. Now learners will convince themselves that if you juggle this, if you squeeze it mathematically, you will have epsilon R equals epsilon over epsilon naught. Check that fact. No, do just mathematics. You are simply checking whether it can also be epsilon naught. I mean, epsilon equals epsilon over epsilon naught. Sorry. No man, how are you? Sure. Is it true? Is it correct? So you can also say it can be defined as. Now we have generated an alternative definition. It can also be defined as. It can be defined as the permittivity of the insulating medium between the plates. Actually, the ratio can also be defined as the ratio. Can also be defined as the ratio of permittivity. It can be defined as the ratio. It can be defined as the ratio of permittivity. It can be defined as the ratio of permittivity. It can be defined as the ratio of permittivity of the material, of the insulating material between the plates. It can be defined as the ratio of permittivity of the insulating material between the plates to the permittivity of free space. to the permittivity of free space. Examples. Yeah. Which way? The ratio of to the No, you can't repeat the ratio. The ratio is 1. You only take us through what will be the numerator of the ratio, 2, the denominator of. So it can be the ratio of the permittivity of a dielectric to the permittivity of the vacuum. Yeah. Examples. I have about 4, which we can try and then go to another thing. Calculate the capacitance of a pair. Calculate the capacitance of a pair of parallel plates. Calculate the capacitance of a pair of parallel plate capacitors of area 25 centimeters squared. Of area 25 centimeters squared. If they are separated by a piece of perspex, if they are separated by a piece of perspex, if they are separated by a piece of perspex, perspex 0.1 millimeters, 0.1 millimeters thick, 0.1 millimeters thick, and relative permittivity 3.5. And relative permittivity 3.5. Analysis or solution. What do we know? We know the area as what? 25 centimeters, but we cannot use it while in centimeters. So how many meters squared are in 25 centimeters squared? Give me the direct answer. Me, I don't want to go through 1 meter squared equals this. Yeah. Where is your computer? Where is yours? People, your computers will get missing. 0.0625. Really? What have you used as the conversion technique? Something like 0.0025. Meters what? You literally have to divide by 10,000. Okay, what else do we have? Yeah. The separation D as 0.1 millimeters. Still, we cannot use them while in millimeters. How many meters are in 0.1 millimeters? Tell it, you give it to me in scientific notation. 1 exponent -4 meters. What else do we know? Relative permittivity as 3.5, and what are we supposed to find? the capacitance. This is direct substitution. Please do it. Are you two people feeling hot or cold? So if it's hot, why are you putting on cardigans? It's cold. Or you also don't know how you're feeling. So you need jumpers at this or during this temperature. I am waiting. Pardon? Huh? No. Check your facts. What did you do? Let me first. Wake up. This is the permittivity of that perspex. Huh? My daughter. Are you sure this is the permittivity E of perspex? Or that is the dielectric constant? If you have the dielectric constant and you're looking for the permittivity of, what do you do from there? You know this. Look here. If you know this and this, can't you get this? Is it what you have used? I've said you try the number. I've made your analysis. Yeah. Okay. Then you try in my presence. What is this? It is merely E naught. This arrow is not there. The other one was a full stop I wanted to put. So how could you define that? And you couldn't ask. It's what she also has. Let me see. If she doesn't have it, you are lying. Yeah. And she convinced you. Then why did you leave it there when you were not convinced? It's E not just. It's not E not R. Are we moving or we are stuck? We should be moving. Are you progressing, Ivan? You are not. You are lying. This permittivity here is not this. This is merely relative permittivity. You need the permittivity of perspex. Yeah? What is this? You are lying. The medium is this one. Yes. How far? You are lying here. You people, all of you, look here now. I try this one, and then you try others. Can we look here? If we know the area of the overlap of the plates of the capacitor and the separation plus the relative permittivity, ladies and gentlemen, relative permittivity is not the permittivity of perspex. It is simply the ratio of permittivity of perspex for this example, for the case of this example, and the permittivity of free space. Meaning, before you even substitute in the equation for finding the capacitance of the capacitor, you're supposed to first get the permittivity of perspex, which is from relative permittivity ER equals permittivity of the medium, right? Divided by the permittivity of free space, right? We can get the permittivity of the medium, which is E equals E naught ER, right? So the permittivity that we are going to substitute in the equation for finding the capacitance of that capacitor is epsilon times area divided by separation. Are we together? So this capacitance is going to be, this is E naught ER, right, times A over D. So the capacitance is going to be E naught times ER, which is 3.5, times A over D. So the capacitance will be the value of E naught, we have it, don't we? ER, we have it. A, we have it. D, we have it. And then you compute. Okay, what do we get? 7.74. Give me to two decimal places. 7.75 exponent negative 10 farads. Example 2. My daughter there, are we together? Any questions yet? Make sure that you're not misled by the relative permittivity. You can't directly, you substitute it and then you go on with the computation. Example 2, 2 microfarad capacitor, 2 microfarad capacitor, 2 microfarad capacitor that can just withstand a PD of 5,000 volts. 2 microfarad capacitor, 2 microfarad capacitor that can just withstand a PD of 5,000 volts, that can just withstand a PD of 5,000 volts, uses a dielectric with a dielectric constant 6. Uses a dielectric with a dielectric constant 6, which breaks down if the electric field strength, which breaks down if the electric field strength in it, which breaks down if the electric field strength in it which breaks down if, is some electricity burning? Kasasiro. Or somebody is frying silverfish. You know, in the barracks there, a certain person had prepared silverfish very well. These Banyankole here are stubborn. So somebody came out of the house. I think he was a soldier. He asked in Swahili, nani yuko kuchoma kasasiro hapa? Jamaa mwenye ambao alikuwa anapika mkene yake was like, this person is taking my sauce as kasasiro, honestly. So these Banyankole, for them, they don't mind. Can embarrass you from nowhere. So the person who was preparing the silverfish felt really embarrassed, humiliated to the max. So it is better you first of all find out whether what you are going to ask is not going to offend others. And proudly somebody, ni hayo cha kasasiro. Nani yuko kuchoma kasasiro wa jameni? Kumbe it is somebody's very good fish. I've said uses a dielectric with a dielectric constant 6, which breaks down if the electric field strength in it exceeds 4 exponent 7 volts per meter. Volts per meter. 4 exponent 7 volts per meter. Huh? Where are you stuck, young girl? I've said the electric field strength in it exceeds 4 exponent 7 volts per meter. Full stop. Find the Roman 1. Find the Roman 1. Thickness of the dielectric. Thickness of the dielectric. Find the thickness of the dielectric. To effective area of each plate. Effective area of each plate. And the third one, you write it, but we shall solve it after looking at it in future. 3, energy stored per unit volume of a dielectric. Energy stored per unit volume of a dielectric. Well, solution. What do we know, ladies and gentlemen? We know the capacitance. Please talk to me. It is 2 microfarad. What else? We know the PDV, 5,000 volts. We know the dielectric constant or the relative permittivity, 6. We also know the electric field intensity, isn't it there? As what? 4 exponent 7 volts per meter. Now, we're supposed to find 1, the separation D, 2, the area, and then 3, the energy per unit what? Volume. I'm saying this one, we shall look at it, we shall solve it later on after looking at the energy and energy per unit volume stored in a capacitor. So for Roman 1, we're supposed to look for the separation or the thickness of the dielectric, which if you refer to our notes or if you look at the unit of the electric field intensity, it is given in volts per what? Per meter. So I am asking, do you remember another approach of finding electric field intensity apart from Q over 4 pi epsilon r squared? Do you remember another approach of finding the electric field intensity? That is what it gives, Q over 4 pi epsilon r squared. The other way is referring to that way, and the unit in which E is given, you realize that this is V out of what? Out of area per meter. It's V out of D. Isn't it? E equals V over, we defined it as the potential gradient. Don't you remember that? Open, check your notes. Don't we have anywhere that electric field strength can also be defined as the electric potential gradient? Is it there? Is it there? Is it there? Huh? Meaning you people, you don't revise. You don't quote. You take your notes as the Bible. You know the Bible is written in number 1, books. Right? Book. And the Bible has, I think, 66 books, right? Then from there, it is written in chapters, isn't it? Then to verses, such that whoever is going to preach will come and say, open the book of Genesis, chapter, verse, and you go look. So you should also take your notes in terms of number 1, books, chapters, and verses, such that you can refer to your own book, your own chapter, and your own verse. Are we together? So where V is the electric potential and D is the separation of the plates. Are we together? So the separation of the plates, in other words, because when the plates are separated and a dielectric is placed between them, right? Meaning that the dielectric is going to run from one plate to another plate. Are we together? In other words, it is also the same as the thickness of the dielectric. Are we together? Because if this is a plate and you insert let me assume the plates are a little taller. If those are the plates and you insert a dielectric that runs from one plate to another, are we together? When you get the separation D, you will, in other words, have calculated the thickness of the dielectric between the plates. Are we together? So having E, having V, can't we find D? So we shall have 4 exponent A7 equals 5,000 divided by D. My audience can convince themselves that D is going to be 5,000 divided by 4 exponent what? What do you have if you compute it? 1.25 exponent negative 4 meters. Can I give you a chance to try Roman 2? Yeah. Let me pass here. I have negative 4. I am going to teach you how to use a calculator the way I teach the senior twos. When you're dividing by something that is an exponent, put it in brackets. Otherwise, a computer will only divide by 4.0. The times 10 to power 7, it will assume it is in the numerator. I'm sure people had gotten some different answers from mine. Is it what you have? Is it what you have? I am waiting for the solution to the area. Hmm? Oh, I have a different figure here. Yeah? What do you have? What are you finding? The area. What is this? This one. Human, you are isolated. What do you have? So the area is 4.7 meters squared. We continue. Do you have the value? 4.7 meters squared. Anybody is stuck? Gentleman behind there, are you with us? Eh? You man, talk to me. Are you with us? You don't have the value? Do you have the value? Help them. You help those ones there. Mm-hmm. Are we together, my brother here? Example 3, a parallel plate capacitor. A parallel plate capacitor. A parallel plate capacitor. A parallel plate capacitor has an area of 100 centimeters squared. A parallel plate capacitor has an area of 100 centimeters squared, comma. Plate separation of 1 centimeter. Plate separation of 1 centimeter. And charged initially with a PD. And charged initially with a PD. And charged initially with a PD. Of 100 volt supply. Of 100 volt supply. Comma. It is disconnected and a slab of it is disconnected and a slab of dielectric and a slab of dielectric 0.5 centimeters thick and a slab of 0.5 centimeters thick and a slab of 0.5 centimeters thick and relative permittivity 7 and relative permittivity 7 is then placed between the plates. Is then placed between the plates. Full stop. Part A. Before the slab was inserted, part A, right, part A, then say, before the slab was inserted, calculate, before the slab was inserted, calculate, before the slab was inserted, calculate, Roman 1, capacitance. Capacitance, Roman 2, charge on the plates. Charge on the plates. Roman 3. Electric field strength in the gap between the plates. Electric field strength between electric field strength in the gap between the plates. B. After the dielectric was inserted, find after the dielectric was inserted, find Roman 1, the electric field strength. Electric field strength. Roman 2, PD between the plates. PD between the plates. Roman 3, the capacitance. The capacitance. You man, come and drop off here and here and there, but don't rub the margins. Solution. Let's go through the analysis. Should we analyze as a class? All right, what do we know? We got the area as what? 100 centimeters squared. Quickly take me through the conversion. 0.01 meter squared. What else? Separation 1 centimeter, which is 0.01 meter. Yeah. The PDV 100 volts. Relative permittivity 7. Analyze everything that we have, please. That's all. The thickness of this dielectric that was inserted, whose relative permittivity was 7. As what? 0.5 centi, which you will convert when the time of using it comes. Are we together? All right. Part A is saying before inserting the what? The dielectric. Before we put in the dielectric, Roman 1, we are supposed to find the what? The capacitance. How do we find the capacitance? Having the area and the separation. So capacitance is going to be, now in this case, case A, before we insert the dielectric, meaning the gap between the plates is vacuum. All right? So we shall have epsilon naught A over D. What do you get here? Epsilon naught is a constant, A is here, D is there. Tell me the answer. 8.85 exponent negative meter what? Sorry, farads. Are we together, ladies and gentlemen? Roman 2 is asking for the electric, is asking for charge. So the charge is going to be, if we know the capacitance C and we know V, can't we get the charge? How do we get it? Equals CV. What do you get substituting for C and V? Yeah. 8.85 exponent negative 10. What are these? Coulombs. Then Roman 3, electric field strength, of which if we know the PD, if we know V and we know D, definitely we can get it using that direction. All right? So we shall have equals V over D. You have V and you got D. What do you get as the final numerical value? What you have? Tell it, give it to me in scientific notation. 1 exponent 4 volts. Part B. After there, volts per meter. After inserting the what? The dielectric. After inserting the dielectric. The problem, you love writing more than understanding. Do you know that you are allowed to sit in this class and you leave minus writing anything? You know that it is actually accepted, but it is foolhardy. You know the meaning of the word foolhardy? Yeah? It's foolhardy. It is nonsensical for one to leave class minus understanding anything out of everything that was mentioned in class. For example, for me, I'm a born again Christian. In those days when we are still young, I grew up with a grandmother who going to church was a mandate, a must, every Sunday. To the extent that there was even a period of time that I cannot remember well, whether it was about 4 years, where we could as well go for overnights every Friday. So for me, at this level, if you take me for an overnight, there must be another thing interesting more than merely to pray. Must be something more interesting than simply to pray, because prayer can be made anywhere. So those days I used to, pay attention in church, and pastors could preach. So one time they told us a story of a certain man who did not go to church, but the other one went to church. So this one who did not go to church met the other one who had gone to church. And the one who had gone to church started to tell this man, but you man, you have missed. Today, the man has preached the word of God. This one who had not gone to church was like, are you sure? Yes, you have absolutely missed a lot. This one asked him, what have I missed? What has the man said? The other man was like, the man has said a lot of things. It was wonderful. This one was like insisting, what has the man said? You man. the man has spoken a lot of things to the extent that even people clap their hands, asking him particularly what the man said. The man could not produce any. So we come here and talk a lot, and somebody lives out of class, minus understanding anything. It is possible, but it is foolhardy. In Luganda, if we can translate it, kyabugwagwa, busiru nnyo okuva mu class eno nga toyina wadde n'aka k'otegedde naye kitegeerekeka. It is understandable for you to live when you have not written anything. So my brother, don't be that person who says the man has taught, but asking you out of whatever he has taught, you pick out one concept, you can't. So after inserting the dielectric, what do you want first? What do you want first? The electric field what? Intensity. Now, electric field intensity, we can get it 1 from E equals Q over 4 pi epsilon R what? Square. Are we together? Or we can have it from E equals V over D. But now, if I try to squeeze this, comparing it with what I have, you see that I can get my area as 4 pi R squared. What area, what shape or what figure can we find its area by using this formula? A what? A what? So you go and check with your mathematics. So if I substitute this back here, I'll have this as Q over epsilon times the area. Whereby do I have Q? Do I have the charge? Do I have the permittivity of the medium? Please answer. Do I have Q? Do I have Q? Do I have epsilon? Do I have the area? So maybe that one can work. Do I have V? After inserting the dielectric, do you have V? Do you have D? Meaning I cannot use this. Yes? Q out of EA. Are you sure? When you guys when you insert the dielectric, do you change the charge? Go back and look at the effect of a dielectric. Go back in our notes and we check on what is the action of the dielectric. I think the PD will change, yes, but the charge will not. If what? When you are looking at the factors that were affecting the capacitance of a capacitor, we are looking at those factors versus the PD. We did not interfere with the charge. Did we? Huh? But do you even read these things? Eh? Do you even read these things? Or I stop giving the notes? When we are looking at the factors affecting the capacitance of a capacitor, we were changing the area and looking at the PD. Did we look at the charge? So I want to inform you, the charge does not change. Are we together? You manifest this way. What are you thinking about? You have a family. Look here. Don't go deep in a sea of thoughts. You will run mad. You pay attention here. So charge is not going to change, for your information. But the PD is going to change. So we shall have E equals Q over E what? EA. The charge is 8 point. exponent, then E. I'm interested in E here. My daughter there, I'm interested in E here. What will E be? Are you sure? What will E be? E is going to be E naught ER, right? So we shall have Q over E naught ER times A. Now do the substitution. We cannot use ER alone. Ladies and gentlemen, I don't know what I can do to make you understand that. You can't use ER alone. ER is used against E naught to get the permittivity of that medium. Are we together? Eh? China. Huh? Are you a China? Are you a Chinese? Chinese are the ones with sharp noses and small faces. We can get now Roman 2. What do you have here? 1.43 exponent 3. These are volts per what? Per meter. Or what is it, the other unit of electric field intensity? Newtons per coulomb, right? Roman 2. We are supposed to find PD, right? So PD, which is going to be obtained from E equals V over D. Can we pay attention? Oh, you already know this. So it's going to be obtained from V over, because we know E, we are looking for V, and we know the thickness of the dielectric, right? So we shall have E equals, V will be E times what? What do you get? Do the substitution. Are you sure? What is your analysis? The thickness of the dielectric was not 0.1. Where is it? The thickness of the dielectric. Where is it? I noted it there. After ER. You see? The D after ER is 0.5. Young girl, you are sleeping. Are you done? We still have Roman 3. 700. I have 7.15. Then Roman 3 is asking for the capacitance, which you can get either ways. Q equals CV. You have VA, CE. Q can be CV, isn't it? You have Q. Do you have Q? What are you looking for? Capacitance. Do you have Q? Do you have V? Then you can also find as E, A over D. Of course, the area of the plates did not change. The separation changed. Then this one is E naught ER. What did you get? I have 7.15. What do you have, younger? What do you have? 7. Maybe rounded off somewhere. You have 700 plus plus. Check your conversion. The separation here is 0.5 millimeter centimeters, which is supposed to convert to meters. Write this and we'll go for break. You'll try it. A parallel plate capacitor was charged. A parallel plate capacitor was charged to 100 volts. A parallel plate capacitor was charged to 100 volts and then isolated. When a sheet of dielectric is inserted between and then isolated, was charged to 100 volts and then isolated. When a sheet of dielectric is inserted between the plates, the sheet of dielectric is inserted between the plates, the PD decreases to 30 volts. Calculate the dielectric constant. Of the dielectric. Calculate the dielectric constant of the dielectric. I beg to stop there. In your checking, check the charge you get when you use this. I mean, the C you get when you use this, and the C you use when you get that. Excuse me.